Okay, we're going to be using the data from question number 52, chapter 6, to look at a graph. So what are we looking at? This is vehicle weights, and so we're not really working this question, but it's good just to kind of get an idea of what we're looking at. In short, the actual weight of a vehicle using a scale when it's just sitting there, and another trying to determine the weight of a vehicle while it's moving. So let's take a look at the data. I'm going to use StatCrunch here. First thing I want to do is open the data, and then I'm going to graph it so we could take a look at just a simple scatter plot. Okay, so my x value is going to be the weight in motion, and my y variable is going to be the static weight. So I want to know if measuring the weight of this object while it's moving around will be able to accurately predict the static weight, which is just sitting there on a scale. So let's take a look at the graph. And so now what we need to ask ourselves, does this data appear to be reasonably linear? And I would definitely say yes. So let's take a look at this real quick. So when we make a linear regression, or when the computer makes a linear regression, what it's really trying to do is minimize the residual values. So let's talk how I would do this by hand without using computer technology. And so what I would do by hand if I just was given this data is I would draw a line that I felt went through the data as accurately as possible, and that's called a best fit line. So I'm just going to start my line down here, go through my data, and I can move this around a little bit. So basically, here's what I want my line to do is cut through that data from left to right as accurately and reasonably as possible. And this is just the best I can do right now looking at this by hand. Okay, so my coefficient of correlation, my R value, I would guess on this is going to be very, very high, probably zero 0.9 or higher. And what a residual is the distance from the line that I'm going to use to model the data and any given point. So this point here, so this is a y from the model, and this is a y value from the data. So my residual is basically how far is it from the data to the model, and that's the length of one residual. Again, observed is the data, predicted is the model, and the distance, or the difference, is going to be the value from the data minus the model, and that is going to be my residual. Okay, so what a computer program does when it's doing linear regression is try to get these residuals to be the minimum total net value between all of them. Now it's slightly more complicated than that, so we're looking at all these residuals here, and just against the distance straight up and down from my points observed to the line, which is my model, which is the predicted. So technically what the program does is takes each one of these residuals and squares it and then adds them together. And that is called the sum of the squares technique. So we want to get that small as possible. You do not have to do this yourself. I just want you to understand what the computer is doing for you.